talking about PCR, that is the polymerase chain reaction, where a specific DNA fragment will be replicated in vitro condition. So for that, we need a DNA fragment that is double-stranded. After that, we are putting a heat at 95 degrees Celsius where the two strands has been separated. Then we are putting the primers. These are the primers. When the annealing step will come, this is a whole cycle. When the 60 degrees Celsius to 65 degrees Celsius, primers will come and bind. After that, we will be going for the extension step, that is the 72 degrees Celsius, where we need the DNA polymerase, that's like Taq polymerase and all. So after that, we can see that from one DNA strand, there are two DNA strands has been produced after cycle 1. After that, like cycle 2, from 2 we are getting to 4, and after cycle 3, that is we are going to 8. So that is the normal polymerase chain reaction. When we try to see the chain reaction, how it goes, we are just trying to go for real-time monitoring. Then what we are doing, we will be putting the cyber braid, that is the DNA intercalating dye that will come and bind with the double-stranded DNA, and we can directly monitor if the products are going on, products have been replicated and it is the products are forming, then the cyber braid will be more intercalated into the DNA fragments, and from the graph we can see a proper exponential graph, because in the initiation there is the cyber braid intercalation will be low. When the cycle will goes up, then the cyber braid intercalation will be high if the products are forming, and then we can see the exponential graph over here. So actually we will be using that PCR and qPCR for any kind of molecular diagnostics. Currently for the SARS-CoV-2 we can see only qPCR tests are only the most reliable technique for any kind of SARS-CoV-2 detection, and for any kind of genetic disease detection, SNP detection, for this kind of purposes we need that PCR and qPCR. So this is the qPCR machine. This is the option. When you put it, when you just on it, you can see the lid has been opened, and there are some of my samples I have put over here. Some is the positive and some is negative. So this is the positive and this is the negative samples over here, and you have to put it over here and put the lid close. It will take some time. Now it will go and it will close it. For the positive control, what we have told you, that if the product are forming, then you can see a exponential graph over here, and for the negative control you cannot see any kind of graph because there is no DNA fragment, that is our main control. If the DNA fragment is not there, you cannot see any kind of amplification over here. So that is the main technique of SARS-CoV-2 detection. We are going for this kind of exponential graph. If the primers specific to the SARS-CoV-2 gene is present over there, you can see this kind of exponential graph, and if you are negative, then you cannot see this kind of exponential graph. This linear graph will be there. Here you can see that in the positive control, you can see this is the cycles, and the CT value you have been seen in the report, the SARS-CoV-2 report, the CT value must have been described over there. So here you can see the CT value is more or less 24 or 25 over here, and when you are going for the custom data view, here you can see that there is a very big melt curve is present over here, and for the negative control the melt peak is lesser than the positive control. So from this kind of data you can predict if your disease, like the disease DNA fragment, disease pathogens DNA fragment is present in the sample or not.